You can turn any YouTuber into your own personal AI assistant just by converting their entire channel into a searchable knowledge base. This n8n workflow does that for you in just a couple of clicks, and it costs less than a penny to run. In this video, I'll show you how to build it step by step without needing to know how to code. So if you want to build things like competitor analysis tools, searchable knowledge bases, or even your own AI agent trained on a creator's entire channel and avoid paying for expensive external services, stick around because this is going to be a great video for you. Alright, let me show you what this workflow actually does before we build it together. I start by typing in a YouTube channel handle, click run, and then n8n handles everything. First, it scrapes the entire channel and inputs every video and its metadata into a clean Google Sheet. Next, the workflow automatically grabs the transcripts, and instead of paying for an expensive transcription API, I show you how to do it for free by setting up a service on your own computer. Finally, the transcripts get uploaded to a vector database, and we give our AI agent access to the Google Sheet and the vector database so that it can answer any question we have about that channel. For this demo, I've uploaded my own channel's data, so the agent knows everything about all 80 of my videos. So let's ask it a question. So I'm going to ask, how much do the UGC ads cost to make? You can see it used the vector database, and now it's answering us. It says 15 cents in model credits, which is correct. I mentioned that in the video, and it even quotes us. Now we'll ask it, what cloud services has the channel used to host vector databases for RAG agents? I know specifically I've only ever used Pinecone and Supabase, so that should be the answer it gives us. It used the vector store, and now it's thinking about a response. There we go, it says Pinecone and Supabase. Again, the system is super cheap to run, and I make sure it's the most efficient and cost-effective it can be. I've been a professional software engineer for over 5 years, so system design is what I'm good at. And as always, you can download this entire workflow template completely free. I left a link in the description. Like I said, there's 3 sections, and I split these because each of them does a specific process for each video, and running all of it at once could make it more prone to errors. Alright, now I'm going to walk you through each of these sections step by step, starting out with the Add Videos to Sheet section, which is responsible for going out to a specific YouTube channel, collecting all of the videos and their data, and then adding it all to a Google Sheet. The end result is going to look something like this. So first of all, we have the Edit Fields node, which is responsible for setting the YouTube channel handle. So that means anytime you want to start processing a new channel's videos, you would just come into this node and update the channel handle. To find the channel handle, all you got to do is go to that specific channel's page, and then under the title, you'll find the channel handle. It has an @ symbol next to it. So you would just copy the channel handle and paste it into this field, and you're good to go. So right after this node, we have a HTTP request node, which works in conjunction with this code node to extract the channel ID based on that channel handle that you inputted. Taking a look at that HTTP node configuration, we see the method is a GET request, and the URL is youtube.com/results. And then for the search query, we're sending in the channel handle from that Edit Fields node. So if I execute the Edit Fields node, you can see that the input is that channel handle that we're dragging into this value field under search query. And so basically what this node is doing is it's sending a GET request to this YouTube URL. And so we can mimic this by just copying this URL and pasting it into a browser, and then adding this search query like so with our channel handle. And so this will bring us to this search results page with a bunch of videos from my channel along with the actual channel link. And so this web page is built with HTML code. And so you can see that raw code by right-clicking and clicking View Page Source. And here is that raw HTML code. And so if we execute this node, here's that same HTML code as the output for this HTTP request node that we then send to this code node, which is responsible for extracting certain pieces of data from that HTML, including the channel ID. So if I were to search through this HTML code by doing Command F and searching channel ID, you can see that the channel ID exists in this HTML code. And so all this code node is doing is that same exact process, is searching for channel ID, and then it's extracting it. And so if we execute this step, you can see the output contains that same channel ID that we see here. Now you guys might be wondering why we need that channel ID. Well, it's because these upcoming nodes utilize the YouTube API, which requires us to send in a channel ID, not just a channel handle. This next node is the YouTube Get Many Videos node, which is obviously used for getting YouTube videos from that channel. You need to connect a credential in order to use this node. So to do that, you'd click Create New Credential right here. and then you'd input your client ID and client secret. I have a video going in depth on how to set this up, so you can either check that out and come back to this video when you're done, or you can check out the docs by clicking the docs button right here. Anyway, you're going to set the resource to video, then the operation to get many, and we're going to return all to get all the videos from a specific channel. And for the filters, the channel ID is going to be set to the channel ID coming in from the extract channel ID code node, and you're just going to drag it in like so. And so this node is going to output a list containing every single video from our YouTube channel, whether it's a short or a long form video. So here they are. We get the full list and there's 80 items. So each item contains a video ID, a channel ID, the title, the description of the video, the publish time. Like I said, 80 items were returned, so 80 videos. And if we take a look at my YouTube channel, you can see that I do have 80 videos published. So that is accurate. And even if a channel has hundreds of videos posted, they're all going to be returned in this output. There is a problem though. This data does not contain every single data point we want about each video. For example, it doesn't include how long the video is, or how many likes it has, how many views it has. So to get that information, we have to use the get a video node, which will return more information about each video than what the get many videos returns. If we look inside of the configuration, we see we're again connecting our same credential, then the resource is set to video, and the operation is set to get instead of get many. As you can see, we have 80 items coming in, and each of these items is going to run this node once. So that means this node is going to get ran 80 times. And so we want to just get one video per each one of those runs. And then we're using the video ID from each one of those 80 items. So just drag in the video ID to this field like so. And as for the fields, this is determining what should be outputted from this node. So we could come in here and select individual items to be returned, but we want everything to be returned. So for that, we're sending in an asterisk symbol, which is just a symbol that stands for everything. So I'm gonna go ahead and run that node, and it's gonna get every single one of those 80 videos. It's probably gonna take a little bit of time, so I'll see you when it's done. All right, so it finished up, and as you can see, it's outputting 80 items just like it inputted 80 items. But each one of those items has more data than before. So for example, see we have more thumbnail options, we have the tags, we didn't have the tags before. We have category ID, the localized title and description, a whole bunch of stuff that we can use like the view count, like count, comment count, favorite count. We can even see the localizations, so the video title and description in a whole bunch of different languages. So there's a bunch of really good data for a whole bunch of different use cases, but the one thing it doesn't have is the actual transcription. And there's no way to get the transcription using the YouTube API, unfortunately, unless it's your own video. So if you want to get somebody else's video's transcription, you're not able to use the API, and we have to use a different method, which is what we're going to do in the next section. But for now, let's continue here. This next node is responsible for parsing some of that information and getting things like the duration and whether or not it's a short. So it's getting the duration, and if the total seconds are less than or equal to 180 seconds, which is equal to 3 minutes, then that means it's a short. All right, I just ran that node, and as you can see, it outputted the same information that was inputted, except we also have the, hold on, let me scroll down. We also have the total seconds and the is short value, which is either true or false. So you might be wondering why we're calculating total seconds here when the input has a duration already. Well, it's because the duration coming in is structured in a weird way. It's like a weird kind of time format with PT17S. So what we're doing is sending that through this parse YouTube duration function, and it's just extracting the hours, minutes, and seconds from this string, and then calculating the amount of seconds. And then we're using those seconds to calculate whether or not it's a short form or long form video. I think that's an important piece of information to have in case you only want to transcribe videos that are long form videos. So next up, what we want to do is take all of this information and add it to a Google Sheet. So that's what this next node is for, append or update row in sheet node. So first of all, we're connecting our Google Sheets credential. And again, you're going to input a client ID and client secret, the same ones you use to connect to your YouTube credential. You'll then select the sheet you want to use. So this document list here lists out every single Google Sheet within your Google Drive account. And so you'll have to go and create that first. Here's what this sheet actually looks like. And I'll leave a link in the description for you to download this template for free so that you can just use this template instead of having to input all of these headers manually. Anyway, we have columns for video ID, channel, title, type, seconds, publish time, link, thumbnail, view count, like count, comment count, transcript file ID, transcript link. And so every single column except for these final three are for storing that video data coming from this first workflow. And then back in our update row and sheet node, we have the mapping column mode set to map each column manually. That means for every single column in our Google Sheet, we need to map it to a specific value coming from the input. So for example, the channel ID, we need to pass in the value coming from the input. So we drag and drop the channel ID like so. And for the channel, we're actually grabbing this from our edit fields node. So we have to select the edit fields from the input here and then drag in the handle like this. Then next up is title. And so we're grabbing that from the json.snippet.title. So just drag it in like that. And for the type, we want the type to either be short or video, which means long form video. So to determine that, we're checking if the json.isShort, which is a Boolean value, either true or false. And if it's true, then we have the value equal to short. And if it's false, we have the value equal to video, which like I said, means long form video. And then I think you get the memo. You're going to drag and drop each one of these fields. And then for the link, you have to make sure to include this https://www.youtube.com/watch and then a question mark with a v equal to json.video ID. And once you're done doing that, just make sure to have the column to match on equal to video ID and obviously drag in the video ID from the input. All right, so I'm going to run this entire first section now. I'm going to execute the workflow. And as you can see, the sheet is currently empty. And in a second here, it will be populated with all 80 videos. There we go. Awesome. Okay, now let's dive into this next section, which is used to get all the video transcripts. This first node is the get rows from Google Sheets node, and it has a filter so that it only gets the rows that have the type equal to video, which means we're filtering out the short form videos since we don't want to transcribe those. Then we're sending all of those rows to a filter node, which filters out any rows that already have a transcript generated by checking if the transcript file ID is empty. This next node is a limit node, which will just limit the output to one item instead of all of them. So this is pretty much just for testing purposes so that we only transcribe one video at a time instead of all of them for the sake of the video today. But obviously, if you're in production, then you can get rid of this limit node and just run all of them at once. But anyway, let me run each of these step by step. As you can see, this first node didn't execute. What the heck? There we go. Okay, it's outputting 35 items instead of 80, so that means 35 of our videos are long form and the other are shorts. The filter node will filter out nothing since none of the videos have transcripts generated yet, and it's going to send all 35 items to the limit node, which will just output one of those items. Then this loop over items node will loop over each item one by one and send each one through these 4 steps before doing the next one. And so the first step out of these 4 is the HTTP request node, which I've renamed to transcribe because that's exactly what it's meant to do. The method is get, and the URL is our own custom ngrok URL, which is actually a local service that we're running on our own computer. Now, we could use an external API, but that's going to cost money. That's probably going to cost like 10, 20 bucks a month to pay for a service that will transcribe videos for us. So to get around that, we're going to set up a service on our own computer and do it for pretty much free. If you're intimidated by setting up code on your own computer, I totally get it, and you can choose to use an external service for getting video transcripts. Just go to Google and search for YouTube video transcript APIs and maybe ask ChatGPT how to set them up in the HTTP request node. All you would do is use that API URL here instead of using this local service that we're about to set up. So here is the quote-unquote service that we're using to transcribe the videos. This is it, just 40 lines of Python code that I wrote in like 5 minutes, so it's nothing complicated. And you can grab this code by using the link in the description. So basically, it's using the YouTube Transcript API Python package to transcribe the videos based on the ID that we send in from the HTTP request node right here. And it's also utilizing a web share proxy that will automatically rotate IP addresses so that we don't get blocked. Once it gets us the transcript, we format it into segments with a start time, an end time, duration, and the transcribed text, and then we return that segments back to our HTTP request node and it'll output it here. Now we're running the service locally on our computer on port 8000, but since you're probably running your n8n in the cloud, it won't be able to communicate with your local service. So to get around that, we set up a simple ngrok proxy, and once we start this Python file up, it'll give us a URL that is accessible from the internet. So we take that URL and we use it as the URL in our HTTP request. As you can see, it says ngrok here. Obviously, in order to run this, you're going to have to install Python on your machine, and you can just ask ChatGPT how to do that real quick. It takes like 2 minutes. By the way, the integrated development environment that I'm currently in is called VS Code, so you can easily download that too. Again, download the folder containing this code using the link in the description. Then to start the service, it's super simple. You're just going to open up a terminal and make sure you're in the directory where your Python file lives, and you're going to run these 2 commands. This is the first one, and it might be different on Windows, so I'll leave a screenshot for that. And then this is the second one. So here is our ngrok tunnel URL that, again, you can copy and then paste into the HTTP request node like so. So I open these up side by side so that you can see what happens when we run this HTTP request node. So as you can see, it finished up and we got a log in the terminal showing us that the service was used and it was successful. And so if we take a look at the output in our HTTP request node, we see we have the segments list containing our transcript. It's a very long list. One thing I do need to mention here is the web share configuration. Technically, you don't need this to have the service work, but your IP will end up getting blocked if you use the service too much. So to not get blocked, you need to use a web share proxy, which will rotate the IP addresses. I think I'm paying like $3 per month for this, so it's pretty cheap. You'll just need to go to webshare.com and sign up for an account, and then sign up for the rotating residential proxy, and then grab your proxy username and proxy password and paste them into the Python file here. Okay, so once the HTTP request node returns these segments, we want to actually take those segments and convert it into a file so that we can upload it to our Google Drive. Now, what you could do is save it to the actual sheet here in a cell, but since the transcripts are very long sometimes, the Google Sheet has a limit, and so you won't be able to store it all in a cell. So instead of that, we're going to actually upload the transcript to a file in our Google Drive and then save that file ID to the sheet in the transcript file ID column, along with that transcript file link in this column. So like I said, we're going to use this convert to file node to convert that raw data into a JSON file. So the operation is convert to JSON, the mode is each item to separate file, and the put output file name is data. And then we're setting the file name to the video ID with a .json extension. So I executed that node, and here is our file. Now we take that file and send it to the upload file node, and this is going to again connect to our Google account via a Google Drive credential, and we're using the same client ID and same client secret. Then we're setting the resource to file, the operation to upload. The input data field name is data, so this has to match the incoming file name, so data. Then the file name we're leaving empty because if it's not specified, then the original file name will be used, and here is the original file name that we set in the previous node. Finally, we select which folder we want that file to be uploaded to. So I recommend creating a dedicated folder in your drive for these files. I just went ahead and created one called My Video Transcripts, so I'm going to select it from this list. There it is. And finally, the last step is to update that row in the sheet with the file ID and the link returned from the upload file node. And so now if I run this entire workflow by attaching the trigger manually node to it and clicking execute workflow, it'll grab all the rows and start transcribing that one since we put a limit on. It's going to upload the file to our drive and then updated our sheet. Let's take a look at the sheet. There it is. We have the file ID and then the link to the file. So let's open it up. And here is a bunch of crazy text that we can't really interpret, but we know it's the segments of our transcript. So since we have this filter node that is filtering out rows that are already transcribed, we can run this workflow and not need to worry about spending the time to process rows that are already done. So I'm actually going to set this limit to something like 10 and then let this workflow run, and I'll let you guys know when it's done. All right, cool. So it finished up successfully, and I like to watch the service run while the workflow executes, so I hope you can appreciate me putting it side by side like I did. Anyway, let's check out the Google Sheet. Yep, there we go. We got our transcript file IDs and transcript links for a bunch of our videos here. Now it's time to go over this final section that uploads those video transcripts to a vector database. So again, we started off by getting all the rows in our sheet and filtering for the type equal to video so that we don't get any shorts. Then in this filter node, it will filter out any rows that don't yet have a transcription by checking if the transcript file ID is not empty. All of this down here is for checking if the video transcript was already uploaded to the vector database, and I'm going to revisit this later on, but for now we're going to move past this. So again, we have a limit node which will limit it to just one for testing purposes, and then we loop over each of those items. So first, it downloads the file from our Google Drive by passing in the transcript file ID that we saved to the Google Sheet. Then we pass that to the extract from file. And we need this because when we download a file from our Google Drive, it's downloaded as a binary file. And so we need to extract the raw JSON data from that binary, and that's what this node does. So let me show you what that looks like by executing this workflow so far. I'm going to move the trigger manually down here and execute this. All right, there we go. It extracted from the file, and here is our JSON. And here are our raw segments that we generated earlier in our transcription workflow. Those segments are then sent to this code node, which will basically pre-chunk all of our data. I wanted to include the title in each chunk so that the embeddings model will take that title into consideration. Each one of these strings or chunks is 1,000 characters and includes the title of the video at the start. We then join each chunk of text with a double line between the chunks. So the output is just this big blob of text with these double lines between each chunk. So that blob of text is then sent to our Supabase vector store node. And so first of all, we need to connect our Supabase account via a credential. So click create new credential, and here is where you'll input your service role secret and your host. I have a video on connecting Supabase that I'll link here. Then the operation mode is insert documents, and we're choosing the table from this list, and I named mine YouTube Knowledge v3. So to create a new table for this purpose, you'll want to go into your Supabase account and go to the SQL editor, and I'll leave this script right here in the description so that you can copy and paste it. But here is the table name, so you can give it any name you want. You just need to make sure that this name lines up right here, and right here, right here, and right here. And then once you click run after doing that, you're going to get a brand new table created, and you can view it in your table editor, and it'll contain an ID column, a content column, a metadata column, and an embeddings column. And so this is your vector database. And as you can see, I've already uploaded some chunks, and the content contains the title at the start along with that content from our transcript, like you saw in the code node. Now, whatever you put here for the match and then the document name, you have to copy this and paste it into this options query name field here. You'll leave the embeddings batch size to 200, that's good to go. And real quick, I'm going to show you how to hook up this default data loader from scratch. So you would click this plus icon under document, you would choose the default data loader, and then for the type of data, keep it as JSON. And since we're inputting all of this text from our previous node, we want the mode to be load specific data, and then we're going to drag in that full text like so. Then for the text splitting, we want to split that full text by those double lines we used in the code node. We'll choose the custom text splitting, and now we can add a custom text splitter. So click the plus icon down here and choose the character text splitter, and then add those double lines in here. That's going to chunk our content the same way we chunked it initially in our code node before we combined it all into a big blob of text. So the last thing to worry about when uploading content to a vector database is the embeddings model. So here is our embeddings model that we attached. We're connecting our OpenAI credential, and we're choosing the text embedding 3 small model. So that's going to take each chunk of our content from the transcript, embed it, and then upload it to the Supabase vector database. Once all of those chunks are done uploading, you'll be able to see them in this table view in Supabase, and then it will move on to this merge node, and merge nodes always wait for all of the inputs to complete before moving on. After all the transcribed segments are chunked and successfully uploaded to our vector database table, the workflow will proceed to the merge node. This node serves as a synchronizer, ensuring that all the inputs are completed before moving on to the next step. I set it up to pass through the data from the extract from file node, which limits the next nodes to only run once per video. That means this update row and sheet node is just going to run once per video, and in here, all we're doing is setting the vector status to added, so that's giving us a visual indicator in the sheet, letting us know that the row is done being processed. And after that, it loops back around, and this loop over items node will loop over each of our videos until they're all done being uploaded to our vector database. Now I'm just going to clear out the vector database and start fresh so we can test this out together. There we go. And now I'm going to run this workflow by clicking the button, and here we go. Right now it's just limiting it to 1. So here it's uploading. The merge node waited for both inputs to complete, and then it updated the row and sheet with the status added. So let's check the sheet, and there's the one that was added. We can see with the visual indicator. And if we look at the Supabase vector store and refresh, there are our items. Awesome. Now, one important thing that I accidentally glossed over is adding metadata to each chunk. Metadata is important because it allows you to filter and enrich the search results when searching the vector database. So in the default data loader, you'll go to add an option and click metadata, and here is where we can add our metadata properties. Now, the metadata is stored on the vector database in the metadata column here. As you can see, it already has a couple of things like the source and the blob type, but we want to add more things like the video ID, the title, the view count, the like count, stuff like that. Okay, so I've added all the necessary metadata properties, and now I'll just drag in the values from the loop over items output, which contains the video data. So we've got type, we've got title, we've got channel, video ID, channel ID, like count, view count, published at, comment count, and duration in seconds. With these metadata fields in place, our AI agent can now filter retrieval results based on any property we define. So instead of just pulling the most similar chunks, we can tell it things like only reference videos with more than 1,000 views, or only use clips from videos longer than 10 minutes. And because we're also storing the video ID and channel ID, managing the data inside the vector database becomes way easier. If we ever want to remove everything related to a specific video or an entire channel, we can just delete all the chunks tied to that ID instead of hunting them down one by one. So I just re-uploaded those chunks with the proper metadata, and as you can see, they're all here. So now let's get back to the start of the workflow. I told you guys earlier that we'd come back around to this part. Basically, what it does is it makes sure that the vector database doesn't have duplicate data. This if node checks if the incoming row has a vector status of invalidate. So if we wanted to re-upload a transcript file for whatever reason, we would just mark this row as invalidated. And in that case, the Supabase delete a row node will delete all the chunks that have that video ID as a part of its metadata. And then obviously that chunk will get re-uploaded with the updated transcript data later on in the workflow. So if we take a look at this delete a row node, all we're doing is targeting the same table that has our data. And then for the type of filter, we're selecting string and then building it down here. So it looks a little weird. All you got to do is copy and paste this. We're basically targeting the rows or the chunks that have the video ID equal to the video ID coming in from that row. Now let's talk about this other branch. So this will run for every row that doesn't have the vector status marked as invalidate. First off, it aggregates those rows into one single list. This list with all of our video data is then sent to the get many rows node for Supabase. And here we're connecting the table and we're returning all. And then the filter is a string again, and we're doing another weird little filter down here. So just copy and paste it. So basically it's targeting the video ID within the metadata and checking if that video is a part of the video list coming in from the input. And so this will return all the chunks that exist for these videos. Since we just uploaded a video, let me show you what I mean by running the workflow. So this node returns 17 items, which means there are 17 chunks for that one video that we uploaded. And if we look in the vector store, we can see that yes, there are 17 chunks for that one video. A bunch of chunks just got added for that video we processed, but don't let that confuse you. So these chunks, these 17 items are sent to the edit fields node that will basically just extract that video ID. And yes, there are just 17 items here with the same exact ID. And so that list is sent to the merge node as the second input. And as you already know, the merge node will wait for all the inputs to be done before moving on to the next step. If we take a look inside the merge node configuration, the mode is combine. It's combining by matching fields, and the field to match on is video ID. The output type is keep non-matches, and the output data from is input 1. What that means is any of the rows coming from this first filter node whose video ID matches any of the video IDs coming from this edit fields node are going to be filtered out. This will make sure we don't reprocess videos that have already been processed and uploaded to the vector database so that we don't have duplicate data. If we look at our vector database, we have 24 records in here right now. So if I run this workflow again, we should see that amount returning from the get many rows. And yeah, we do. And then those 24 items contain 2 video IDs. So we have this one that starts with NX and this one that starts with LR. And so those are sent to the merge node, and any of the rows coming in from the filter node that match those IDs are filtered out And so as you can see, 11 items are being sent through, but only 9 items are being returned. So the filter is working properly. Okay, that's going to do it for that section. And the last piece to this puzzle is the AI agent whose job is to use the data from this vector database to answer any question that we have. Before we get into that, I'm going to upload all the transcripts to the database by removing this limit or setting it to a high number like 20, and then clicking execute workflow. All right, we'll let that run. All right, there we go. If we take a look at the vector store in Supabase, let's refresh. And we got 280 chunks. And the sheet has all of those vector statuses set to added. Now let's talk about this AI agent. So first off, it's connected to the chat trigger so that we can send it messages in this chat area down here. It's connected to the OpenAI GPT-5 model, which is what it will use to process our messages and use the tools that it has access to. We gave it some simple memory so that it can reference past messages. And as for the tools, we give it access to the Google Sheet with the video data, and of course the vector store with the actual video transcript data. To configure the Supabase vector store tool, we're connecting our same credential. The operation mode is retrieve documents. And then the description, it has to be a detailed description describing what this tool does. So this tool searches the Supabase vector store for the most relevant YouTube transcript sections and returns them for reference when generating new content. The limit is 8. We include metadata, of course, and for the options, the query name has to match what the function name is in our vector database. So again, in the SQL editor, this right here needs to match this. Then obviously make sure you choose the correct table name, so YouTube Knowledge v3. And then for the embeddings model, we're connecting the embeddings model that we already have created up here. But of course, you could just copy this and paste it down here if you want and connect it like so. You just have to make sure that the model is the same exact one we use to embed the data when uploading the data to the vector database. And finally, let's talk about the actual agent's system instructions. So I'll open up the agent configuration and I'll open up the system message into a bigger view. So first of all, we have the role. You are a specialized YouTube content analyst. Your sole purpose is to answer user queries based exclusively on 2 specific data sets. You do not use outside knowledge or general internet search. Then we go into the data source and capabilities, so what each tool is capable of. Then the decision logic, you must evaluate the user's intent to choose the correct workflow. Then we go over those specific workflows. So quantitative queries, if the user asks for the most viewed video or videos from 2023, query the Google Sheet first to identify the specific videos. And then qualitative queries, if the user asks, what does he say about Python or summarize the cooking advice, query the vector database. Then hybrid queries use both of the tools. And finally, down here, we go over the response guidelines, citations, accuracy, and context. So that's all. It's a pretty thorough system instruction, and it's important so that our agent is consistent, accurate, and knows exactly what to do. Again, you can download this workflow in the description so that you can just copy and paste this system instruction without having to type it out yourself. What I'm going to do now is run the rest of my videos through these workflows. So I'm going to get the transcripts and then upload them to the vector database. And then from that, we're going to see how much this all costs. And we're going to test the AI agent with a bunch of questions. So let me show you what my current balance is on OpenAI, since we're using OpenAI to do the actual embeddings. So right now it's $1.43. So let me connect this trigger manually node to the get video transcript section and give this a run. All right, so that just finished up and it did 20 videos. So now we're going to connect the trigger manually node to this next section and run those 20 videos through this workflow and upload them to the vector database. So let's run this. I just realized that the limit we had up here for 20 wasn't enough. So we still have to upload a few more. Let me do that real quick off camera. Okay, that's done. Now all of our videos have transcripts. Well, all of our long form videos have transcripts. And so total, it's about 35 videos. And let's look at the billing information for OpenAI. If I refresh, it didn't change at all. So I think it's just super, super cheap to run the text embeddings 3 small, which is our embeddings model that we're using. So we ran through 24 videos just now, and here on the usage page, it's showing us that we only used less than 1 cent to run all of those 24 videos. So either it's really cheap or it just hasn't updated yet. So I'm gonna check back in like 5 to 10 minutes to see if this changes. And in our vector store, there's a total of 716 records now. So 716 chunks of data. So now let's test our AI agent. I'm gonna open up the chat and I'm gonna ask a qualitative question. So something about the actual video transcripts. I know that I have definitely talked about two services for RAG AI agents, Pinecone and Supabase. So I'm gonna ask it, based on the transcript data, what cloud services has this YouTube channel used for RAG AI agent vector databases? All right, I'm gonna send that off and our AI agent is thinking and it's going to use this tool, I hope, and it is. All right, we should get a response here in a second. From the transcript data, the channel has specifically used and or demonstrated these cloud services for RAG, Pinecone, Supabase, and self/locally hosted options like Qtran, which is true. Now we'll ask it a quantitative question like, what is the video with the most views? Send that off, and it should use the Google Sheets tool. There it goes, yep. Build anything with OpenAI's new OSS model, 97,000 views, and it even gives us the link. Okay, that's it for the build. Remember, you're not limited to one creator. You can load multiple YouTube channels into this database and instantly turn them into personal AI assistants. Imagine uploading all of Alex Hormozzi's videos and asking it for business advice, or loading a real estate channel and asking it how to start investing, or even comparing entire channels side by side for competitor analysis. If you found this helpful, make sure to leave a like on the video. It really helps the channel out, and subscribe for more content like this. Also, make sure to check out the free community linked in the description, where I upload all of these templates for free, including this one. Thanks for watching until the end. I'll see you in the next one.